So good afternoon, everyone. This is Samarth, and as you guys might be aware, that we are starting with PYQs over the 3D geometry, and we'll do some questions over the same. And let's, without wasting much time, let's get into the questions. So the first question says, find the coordinate of the point which divides the line joining this into the ratio 2, 3. Okay. So this is a very direct question. So if there's a point, let me take a point. Okay, my pen is not working. What? Just give me a minute. I'll attach my pen and come back. Just give me a minute. Excuse me. So there is a technical issue. I'll be just back in a minute. I'll have to restart my laptop. So if you could give me a minute, I'll be rejoining. So good afternoon, everyone. This is Samar, and we'll be continuing 3D geometry and doing some PYQs of the same. So without any wasting any time, let's start with the first question. The first question says there's a point P, there's a point P, and there's a point Q, and there's another point which divides this line joining them into a ratio of 2 to the point is this and Q is. So we can directly get the coordinates of R by using the formula, that is 2 times of 4 plus 3 times of 6 upon 5. This gives me 8 plus 18, that is 22. 22 by 5 is our x coordinate. Then another thing that we have is 6 plus minus 3 upon 5. So that is 3 by 5. So the points we get. And now for the externally, we what we do is we take 3 as negative 3. For externally, the point it seems like this: P, Q, and R. So this is 2 and this is 3. So we take negative 3 in the we change the formula by taking 3 as negative 3 and we get the answers. So quickly moving towards the next question. These are very basic questions, guys. It is nothing application of a 3D geometry part. This was very basic. So find the points on the x-axis which are at a distance of 2 root 6 units from the point this. Okay. Since the points are on the x-axis, so what we can say is that their y and z coordinate are zeros. So this is what the point is. So h minus 1 whole square plus 2 whole square plus 3 whole square is equals to 4 times of 6, that is 24. So h minus 1 whole square is equals to 24 minus 9 minus 4. That gives me 11. 24 minus 9 is 15. 15 minus 4 is 11. So h minus 1 is equals to plus minus root 11. And h becomes this. That is 1 plus root of this. This is what our answer is. That is 1 plus minus of root 11. Another thing that we have here is if a line makes an angle base with OX, OY, OZ respectively, then prove that. Okay. So one thing that we understand is it is the same as the illustration as the solution. Say I read a solution for you in this question because to prove that question. So what we have, let L, M, and N be the DCs. And what do we mean by DCs? DCs are basically the cosines of the angle which they make with the x-axis, y-axis, and z-axis. Right. So I'm not knowing the complete full form of DC here, but it's like related to cosine basically. So what we do is we take cosines. So we have L is equals to cos alpha, M is equals to cos beta, Y is equals to cos gamma. And we know that this is right? We know this property exists, don't we? We know, right, that if L, M, N are DCs of the line of any line, then L square plus M square plus N square is equals to 1, right? This is the formula. And now taking this formula forward, we have this equation. It's a very simple equation, nothing out of the box. We're just using the property that cos square theta plus sin square theta is equals to 1. Moving towards the next question, we have projection of a line segment on the axis are this and this. Find the length of the direction cosines. Okay, so these are direction cosines of the line segment. So okay, so let's read the solution. The solution says let L, M, N be the direction cosines and R be the length of the given segment. Okay, so what we know, these are the projections. These are the direct projections, and this is what we get under the projections. LR, MR, and NR. These are the points. And when see, without mincing our words, let's focus. So if L, M, and N are the DCs of a line, then and R is the length of the line. Length of the line segment, then LR, MR, NR are the projections on the lines, right? Or like on the axes. So this is what we get. And we know the values of these. We already are given these values. That is equals to 12, 4, and 3. And squaring and adding them gives me the value of R, because one thing we already started in the next second question, question number 2, that L square plus M square plus N square is equals to 1, where L, M, and R DCs. So this is what we have, and we get the value of R. Right? Now moving to the next question we have. Moving to the next question number 5. The question number 5 says, find the length of the perpendicular from the point 1, 2, 3 to the line this having direction ratios as this. So one thing to remember is when we know the direction ratios, I don't think this formula is correct though. So direction ratios are known. So after, if we know direction ratios, we can easily find the direction cosines. How do we do that? We divide them by their squares, square roots, sum of squares, and then taking the square root of it. So we can find the direction cosines very easily like that. So we have the direction cosines with us. Then the formula, the AN part becomes very easy for us to find out. So AN, the projection of AP on AB is equals to this. So this is the formula that we have. And I think you have to remember this formula to find what is R. If we have to calculate the perpendicular length, that is the PN, but the formula for AN is known to us. So what does AN look like? AN looks like L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1. So this is the length of AN. So what we get is the length of AN we know. So if we know AN and we know AP, then calculating PN is not a tough job for us because we know that Pythagoras theorem is applicable on any right triangle. So we apply the Pythagoras and find out the value. Now moving to the next part, we have find the equation of the plane through the points this. So again, it is a very direct question. Okay. So it is again and formula based. So I'll highlight the formula that is important here. So this is what we have. Just okay. So getting back to this question. So this is what we have. The general equation of a plane through 2 minus 1 is this. Okay. Then we have three equations and three variables. So solving ABC would be really easy for us. So we get the value of ABC. And we get the equation out. So now moving on to the next part, we have find the angle between the planes. So that is also formula based. See, again, this might seem a bit of a theoretical kind of lecture because 3D geometry is all about formulas basically. Because the more formula you remember, the easier it becomes for you to solve. Because here your physical application and your logical abilities can be a bit like you cannot simply solve three variables, right? With the logic and imaginative power, you have to rely on formulas because again, this could be really troublesome to derive formulas. So here in coordinate geometry, you can derive your formulas and work with it if you're not remembering those. But here it is very important for you to remember the formulas. So I would suggest you like just go through the formulas and remember them because they will help you a lot, especially in 3D. So again, we directly apply the formula here. This is the equations that we have. So the angle becomes half and theta becomes pi by 3. Very easy. Moving to the next part, we have find the distance between the parallel planes. Okay. So again, it is a very easier part. What we do is we subtract the coefficients and divide them by the, see the direct formula. Acha, let me just, they don't have the formula here. So let me try if my formula is correct or not. So it is 2x minus y plus 2z plus 3 is equal to 0. Then it is 2x minus y plus 2z plus 5 by 2 is equal to 0. The difference becomes 1 by 2. Because 3 minus 5 by 2 is 1 by 2. And then root over 2 square, 1 square, 2 square. this becomes 1 by 2 into 9, that is 1 by 2 root, sorry, 1 by 2 into 3. So that is 1 by 6. So we get our value. Okay, very easy to solve again. You just subtract the constant terms and divide by the sum of squares, then taking a root of the coefficients. So we are done with the eighth question as well. Now moving to the ninth part. We have the equation of a line R this, okay, is होना चाहिए but वहाँ पे the equation of the line is, okay, find its direction ratios and its equation in the symmetric form. Okay, so this is what we have. Okay, so again, it's very theoretical. I can give you a minute to read it through. This is important stuff. So let me give you a minute, read it through and just understand and see it through. Okay, so I think you must have gone through the solution and now getting to the next question, the question number 10. Oh, wrong pen, let me erase it. Okay. So question number 10, it says find the image of the point in the plane. So the plane is the plane, and we have to find the image. So 3 minus 2, 1. So again, it is a direct question. So x minus 3 by 3 should be equals to y minus 2 by minus 1 should be equals to z. So this would be a plus here. Z minus 1 upon 4 is equals to 2 times of modulus of 333 minus 3 into 3 minus 2 plus 4 times of plus 1. This is a plus 1, right? Yes. Why is it zoomed in? Okay. And we have a minus 2 also. So I'm not sure that if we take a root or not. So we'll check that out. So on solving, what do we get? 16 plus 1, it should be not. What happened? Okay, so just a minute, I'll just reshare. I think I closed the tab by mistake. Yes, so is my screen visible? No, it not must be. So let me share. Okay, so it must be visible now. So yes, getting back, what do we have? My value for x. So Okay. So it was 25 and 25 plus 1 is 26. So root of 26. This is part is right. And how are they calculating the R? I'm still not getting it. Okay, so let me see where am I going wrong. I think there is a problem in calculating R. The R they've calculated is wrong. Or let me check the upper side, what the upper side says. So 9 plus 2 plus 4 minus 2. So it is, this gets subtracted and 13. So yes, it is a whole square here, guys. There should be a square also. I'm giving you a direct formula. So what do we do here is, so the thing is, the formula is basically x minus a upon L, or the coefficient. Let's go with x minus x1 by a is equals to y minus b by c, again y1 होना चाहिए यहाँ पे, y1 by b is equals to z minus z1 by c is equals to 2 times of ax1 plus by1 plus cz1 plus d upon root square. There is no root, so it is a square b square and c square modulus. So we are applying that here. We have 13 and we have 26. So this cancels and becomes 1. So we have x is equals to 0, y is equals to minus 3, and z is equals to 10. We got, so it should be a negative. Y should be a negative. It should be a negative. It should be a minus 2 here. So then 2. Acha, then also I'm not getting it the right value. Why is that? No, I'm getting the right value then. Okay. So 0. Okay, so now we get this value. Minus times of 2. Remember that there should be a minus times of 2. I made a mistake. I didn't took the minus part, so you have to take the minus part. I didn't take the minus part. You have to take the minus part. So I hope you get the formula. I'll rewrite the formula if you want. Just give me a minute. Okay, so the formula is for the mirror image, right? X minus x1 by a is equals to y minus y1 by a is equals to z1 by c, and there should be a b. A b minus 2 times of a x1 . Where it is the formula. And now moving on to the advanced section. You can note down this formula if you want. I'll give you a minute to note it down. You have noted down? Okay. So now move on to the next, or take a screenshot basically. Now moving on to the next question we have. Example 1, find the equation of the bisector planes of the angle between this and specify the plane by setting the acute and the obtuse. So again, it is a very formula based question, guys. I'm telling you, 3D geometry is all about formulas and it can really suck you up. because of formulas. Because personally, I didn't also like learning a lot of formulas. I just wanted to just go with my logic and solve the question. But in 3D, you cannot do that. So you'll have to learn formulas. So again, these are the two formulas that we have. And the equations of the plane we get from this. And now we have to find the angle theta between them, right? So we calculate the theta. And then you can see which is the acute and which is the obtuse. I'll give you a minute to read it. So just read it through. It's a very self-explanatory question and direct application of the formula that you might have studied earlier. So just read it through. I'll give you a minute or half a minute because it's a very short question. Okay. So you must have read it through, and now let's move on to the next question. We have find the distance of the point 1 minus 2, 3 from the plane measured parallel. Okay, so it's an interesting question. We have a plane x minus y plus z is equals to 5. Measured parallelly to the measured parallel to the line whose direction cosines are proportional to this. So okay, we have a line whose DCs are 2, 3, minus 6, and these are not cosines, these are ratios of whatever you feel like you have set the proportion to it. So we'll take dr basically. And we have a point 1 minus 2 and 3. So I have to calculate. Firstly, I'll have to make a line parallel to this. So a line parallel to this with this direction ratios would look like, first of all, 2 times of x minus 1 plus 3 times of x plus, oh sorry, y plus 2. What am I writing? Give me a minute. Plus minus 6 times of z minus 3 is equal to 0. This is what the line is. Okay, so no, the line is this. This is the plane's equation, guys. I'm really sorry, messing up my concept. So this is the line. I'll calculate it for you guys, but sorry for that confusion. So this is the line. So line is x minus 1 by 2 is equals to y plus 2 by 3 is equals to z minus 3 by minus 6 is equals to r. So basically, this is the line or anything. We can take it's a constant also. It's a line. And now we have to calculate the point. So let this be P and this q. So let our q be two r plus 1, 3r minus 2, minus 6r plus 3. This is what we have. And now we have to simply put them in the plane. The plane is x minus y plus z is equals to 5. So let us put it through there. So 2r plus 1 minus 3r minus 1 minus times of, so minus 6 times of. So it is 6r plus 3 is equals to 5. So let us calculate. It is 7r plus 1 this. So this gives me 0. So r becomes r 0. What? R is 1 by 7. How is it getting 1 by 7? I'm not getting 1 by 7. Am I getting 1 by 7? So it's 2. Forgive my handwriting, guys. It's 2. And that 2 a positive. So it is 5. So 5. So it's minus 1 by r, right? It is a positive, so there might be a calculation problem. I'm not getting the depths of it. No, but 1 plus 2. But the r is also negative, right? Achha, okay. So the r is also negative now. So r becomes 1 by 7. Okay. So that was the mistake. R is 1 by 7. So we get the value of Q. So if we know the Q, if we know the P, the distance calculation is very easy, right? So now moving on to the question number 3. What does the question number 3 says? Show that the lines do not intersect. Also find the shortest between them. Okay. So how do we proceed with that? This is what? I'm not getting anything what they're doing in the solution. So the basic thing that you could do is, if they do not intersect, means they are parallel, or there are skew. Basically, there are skew lines, right? So they do not intersect at any point. So if you like simply take it as k and y, so you will not get the uniform value of k and l. Basically, what you do is, just let me show you. See, this is more of a logical way of thinking. This is the formula way. I'll give you some time to go through the solution by your own, but let's not get into it by right now. So if this is equal to k and this is equal to l, and if you calculate for equal values, that is 3l plus 1 should be equals to 4k minus 2, right? 4k, yeah, whatever. Let me write it again for you guys. 3l plus 1 should be equals to 4k minus 2. And then if you solve it for the other equation, you will not get a uniform solution, right? So if you do not get a uniform solution, then 3 equation, that means they do not intersect. So first things first, that is done. Now calculating the shortest distance, what you can do is, you have to calculate the perpendicular distance. So these are the two lines, and you have to calculate the perpendicular distance between them. And you can easily do that by how? Using a formula which says, the formula process. I really don't want to get in the depth of it because I'm really not sure about the process. So I'll leave it for you guys to read it through. You can simply take a screenshot of the solution and read it through by your own. This is the first part, and this is the later part. Again, read it through again. This is the thing, and that is the later part. Okay. So now finding the doing the rest of the solution, what do we have? Find the angle between the lines whose direction ratio satisfies the equation this. Okay. These are the two equations that we have. So again, we know what does the cos theta look like this, and in the terms of ln m is also a formula for finding out cos theta, but we'll not get into it. But let's move the solution here. This is the we have already seen in another question that what is the angle between two lines look like, and what the equation says. This is the equation. So this is what we are left with. So the ratios that we get are these on solving the equation. And how we are also remember that L square plus M square plus N square is equals to 1 can also be applied here. So they have used this here to get a refiner equation or more refined version of the equation, whatever feels right to you. So this is what we get, the direction ratios. And now the angle which comes out from the using direction ratios is this. So very easy to solve, I suppose. Okay. Now moving on to the next question. What do we have? Find the equation of the plane through intersection planes this and parallel to the straight line having direction ratios with this. Okay, so you must have read the solution. Sorry for that. And now sorry, you have must have read the question and now move into the solution. So this is one thing that we know that what is the equation of the family of planes passing through two planes, the intersection of two planes look like. So this is what it looks like. We got this equation. And now since the plane is parallel to this given line, what does that mean? That the direction ratios, right? Our direction ratios have to satisfy this. But this is not correct, guys. What they've done is they've simply taken the values of x, y, z and they have put in the values of direction ratios there. It is not the correct way, I suppose. It's wrong way. But okay, whatever feels right, they must have solved it through. So this is what they've done. I suggest you to just go through by yourself to this question. It's an important question. So again, now making to the next part, we have another important topic to discuss, that is the coplanar part, that what does coplanar mean. So coplanar, you must have heard it earlier, and what does it mean? So coplanar basically means that these two lines lie on the same plane. Okay, so this is again the important thing that to remember, that we know these two lines are coplanar if this is this. So we solve it and we get the value. And the equation of plane is given by this. So we have done this question as well. Now moving to the next part, we have find the equation of the plane passing through the lines of intersection of. Again, very similar question. We can use the family of equation wala concept. So we know that the family of planes would be look like in this. And if it is perpendicular to the plane, then what we do is we put the value again and find the value of k. So parallel, in the parallel part also we did the same thing, and in the this part also we are doing the same thing. What is it? So again, I'll suggest you to go through the solution of these. Not these, this question basically. These two questions are very similar. Here we had been given the direction ratios, and here they were given the planes equation. So how did we tackle them is the very similar process. So please kindly take a note of this. This is really important concept, that what are we doing. In the first question that we did, it was given that the direction ratios should be parallel. So then also the direction cosines. So we took those values and put them in the equation. And for the perpendicular part as well, we did the same thing. Okay. So now moving to the next question we have. Show that the lines this are coplanar and find the equation of the plane with the line. Again, this similar question we did earlier. So I think we can skip through this. Let's do some more questions because we have still some time left. So let's do some more questions. Let's see the direction cosines, or do you want me to just go through with that also for you guys? But since we are trying to focus on the questions today, so let us not just deviate and just continue with the questions. Let me see, do we have more solved example of PYQs? Just give me a minute. Okay, we don't. So we do have solutions for these questions. So let's see, where do we stop at? Stop at basically. So the direction cosine of the line at this, find the direction ratio. So we can say it is 3 minus 2, 6. Very simple. Let me see how do they work it through. Yeah, very easy. Now find the direction ratios of the line passing through points this and this. So how do we do that? The direction ratio is basically the angle, right? As M, and that is calculated as, let me see how to do that. I'm really sorry. So direction ratios are calculated as this. 2 minus 1, 1. So, okay, we just simply subtract the points. So this is what the direction ratios are. Okay, so we are learning side by side. This is done, this is done. Angle, so we know what the formula for angle is, right? Cos theta formula is. Let us check. So the formula is this. First you take the direction ratios and then see the theta part. I hope you get it. Very important to remember. Now, what do we have in the next question? Question number 4. Okay, find the equation of the line parallel to the vector passing through this. Very easy. X minus 1 plus 1 by 3 should be equals to y minus 1 by minus 1. What? Let me use this pen again. It is x plus 1 by 3 is equals to y plus 1 by 1 is equals to z plus 3 by 1. So this is what the equation of the line looks like. Now, the next is write the vector equation of a line whose Cartesian equation is this. Very easier to solve again. You just see the fifth and fourth part. Just give me a minute. This is what it is. And fifth part can be written like this. How did we come about this equation? Rather than taking t, we wrote the lambda and we got the equation. Got it? Okay. So we're done with the fourth question and the fifth question. Now moving to the sixth question. What does the sixth question say? Write the Cartesian equation of a line whose vectors are these and this. So very easy to solve again. What do we have? X minus 3 by minus 2 should be equals to y minus 2 by 1 should be equals to z. It is by 1, not 2, by 1. And then z plus 5 upon 3. This is what the equations look like. Now moving on to the next part, we have find the value of p such that are perpendicular to each other. So by perpendicular, what do we mean? The direction ratios are should be perpendicular, so the dot product should be perpendicular. So 1, 3, 2p. Let me erase it. We have 1, 3, 2p dot product with minus 3, 5, 2 should be equal to 0. So we have minus 3 plus 3 plus 4p should be equal to 0. So p becomes 0. Let me check the solution. Why is it 5 though? Okay, so it was 5. My bad handwriting again took me back. So it was 5. Okay, so now I think we're done with almost all of the questions on the variety that we covered today. So I hope we are done with the lecture. Let me see, do we have more time left? Yes, we do have some time left. So I think we one or two questions more. This is very direct. Again, we took the dot product equals to 0. The next question is write the Cartesian equation of the plane. Very easy. What we have here is, let's check. Okay, so I think that is the solution that we're looking for. So I think we can stop with the questions because we already covered a lot. If you want, we can revise some theory. So let's go to the theory part. I'll open up theories for you guys. So just wait for a minute. We'll just cover a bit of formulas for the revision because we're done with the questions. So I'll give you the formulas. Okay, so let me input them here. So yes, these are some important formulas that you can study and remember. So let's start with the first formula. It's a very basic formula. The first formula states the distance between the 2 points is given by what formula? So I hope you remember this. Then next is the coordinates of the point dividing the equation. So we are aware with this also. Then we have other vertices. The centroid is given by this. Then we know what the segment division looks like. Then we know. Okay, so this is important. I'll circle for this. This is very important. What the direction ratios and direction cosines basically are. Okay. And the other thing that we have, if M and LMN are the direction ratio, so this is again is important. So again, I'll highlight this for you guys. This was a question also that we did earlier. Then if ABC are the direction ratios of the line, then the direction cosines are given by this. Not to mention, if P of XYZ is a point in the plane such that OP is equals to R vector, as this is this. Okay, so again, this is the direct projection formula, that what is the projection on the XY axis is and what do they look like. Then the length of the projection is given by this. These are all, see, again, we had done these questions in JEE mains, right? When we were discussing the question in the JEE mains portion, these were direct questions that came up. This is important, the angle between two lines. Okay, so I think we're done for today. If you have further questions, you can comment down and I'll try to solve those questions for you. But so let's stop the lecture here for right now. Okay. Thank you. Bye.